Hey YouTube, XCity here. Today we are solving Reflection, a chain of 3 vulnerable machines on Vulnlab that covers several Active Directory topics including relaying authentication, MSSQL and ACL misconfigurations. So in order to play this chain you have to be signed up to Vulnlab and then you can use the chain command here and put the name, which is Reflection, and then you get like the menu for the machine. If it's not started up yet, you have to press the start button. I already clicked that one, so I already have the IPs here. And then we can just connect to the VPN and reach the machines, right? There's nothing more to it. Here you can see when it expires, so you have a 2-hour limit, but if there's less than 1 hour left, you can just click the extend button to get a bit more time. And you can do that as often as you want. So to get started, we need to run a port scan, right? So I took these 3 IPs, put them into ips.txt, and then we're just going to like run nmap here and see what comes back. All right, let's see if we got results for all of the machines. Yes, that looks good. So we have a domain controller on .53 here. There's Kerberos, LDAP, secure LDAP. There's MSSQL as well on the domain controller. That's interesting. And RDP, all right. Then we have another system which has MSSQL as well. We even get the version here. RDP2. Well, other than that, we don't really see anything interesting. And yet another machine. Let's see, that's just RDP SMB. So yeah, the only thing that really sticks out at the moment is that these 2 machines have MSSQL. And of course, we get the domain name here, right, which is reflection.vl. Let's put it here. And other than that, we have to now do enumeration without having credentials yet. And we have a couple of options for that. So one thing we can always check without having credentials is to see if we can access a file share without authenticating, like anonymously, right? So let's actually try that. Let's do just see on all IPs, right? We don't really know what to expect here. This isn't working, so let's try the next one. This actually looks good, right? We were able to see the listing of the shares. This is already a sign that there's some kind of like open configuration to whoever can access the share. So let's see if we can actually access this staging share here. Let's just do staging and then remove the L here. And I'm just putting anything here as a password, right? Doesn't matter. There seems to be a configuration file. So let's get that one and just cut it. And we get credentials. So just store them for now. It's saying staging DB configuration, and we saw a couple of MSSQL ports, right? So probably this is authentication for a database. And we found that on 54. So let's actually just cut the port scan again here. On this very machine, there's MSSQL, right? So let's just add this here. We might be able to connect to this machine, right? So let's just try that. And a way to do this is we can use impacket MSSQL client. And then we have to give it the credentials. So let's do staging. Then we just paste the password. And we give it the IP. And this seems to work. We are now on the MSSQL server connected. We don't really know which privileges we have or anything like that, so that's something we have to enumerate. All right, so let's do some enumeration. We can do add that version to get the version. We already saw that in Nmap, so it's not like something huge new. We do see the operating system version here, which we didn't know before, so that's something small we learned. It's a fairly recent build here. It's running inside the hypervisor. All right. And the MSSQL version itself is fairly old, but I'm not aware of any like RC vulnerabilities or anything like that. So we probably have to enumerate a bit more to see what we can do. So let's do an actually select username, Okay, we could authenticate, but we are just being mapped to the guest account. So we essentially don't really have any privileges on this database, but still we can try to enumerate, like, are there any like custom databases, tables, content of tables, and so on, right? So the way we do this is we can do select name from master DBO sys databases and get all the databases on this MSSQL instance. And one of them is staging. And this fits kind of the config thing we saw earlier. So we can use this database. And now we can like try to get the tables inside the database. And again, we would need to query the schema, right? So we do select star from staging. I think it's like this. Yes. So there is a users table inside the staging database. So let's just select everything from it. And we get some credentials here. All right, this is interesting. They kind of look like test credentials though, right? So what you definitely can do at this point is to just try to spray them or just try to use them against the domain, see if they work. I can tell you they don't, but there's a chance, right? Or just take the password and use it on any other users you have on the domain, right? To see if this is like the default starting password that they use. But we don't really have any usernames. In this case, you could use curl-root to find usernames and then try it. That's a totally valid approach. But the thing that's going to help us proceed here is something different. So I'm just going to talk about what else you can do, but we are going to follow the route that actually yields something, right? Don't want to bore you with too much enumeration. All right. Well, one thing we can often do is we can execute the xp-directory command. And what this does is essentially list the content of a folder. At least that's what it's supposed to do. So we can do like exec xp-directory and then maybe do it on C. And it's not really showing the content of C, but it's at least not failing. So we know that the method is indeed enabled. So one thing we can do is point this to our machine with a UNC path, and then it will try to authenticate with whichever credentials this database account is running as, or this database instance is running as against our machine. And maybe then we would be able to like crack the authentication. So let's try that. I'm just going to do SMB server here first. Now I have a local SMB server running, and we'll try to point this to our machine. And you can see that this also doesn't error, and we get a connection attempt here. And the account that's trying to connect to us is SVC Web Staging, which is a domain account. All right. So one thing we can try here is to crack this, but in this case it won't crack. It's a complex password. You can't really crack it. But it's definitely like a good idea to try it. You never know. All right. So this won't crack. So what else can we really do with this? Well, we can potentially relay it. So this is an SMB authentication. We mainly can relay it to SMB as well, but the requirement for that is that the target system has SMB signing disabled. So in order to like get an idea if this is a viable approach, we have to find out if SMB signing is enabled first. So let's see if this actually was in our output before. No, it's not. Okay. One way to do this is using crackmap exec. So we can do CME SMB and then just give it the IPs. I think it accepts the syntax. And then we do again relay list relay.txt, and this will check the SMB signing. So let's do it. And interestingly enough, SMB signing is disabled on all of the machines. So we would even be able to relay this to the domain controller, which is not the default setting. So this is basically misconfigured. Normally, like domain controllers always have SMB signing enabled, but in this case they don't. In case of this workstation here, well, that's normal, right? Workstations always have SMB signing disabled unless someone activated it. And also, like, this gives us the name of the machines. We didn't really have them before, right? So this is always also something new. All right, now we know that SMB signing is disabled everywhere, and we could just try to relay it to either of the other machines, like the workstation or DC, doesn't really matter. We don't know yet, right? So let's create a file here and call it targets.txt. And for now, I want to relay it to the domain controller, which is the lowest IP here. And then what we do is impacket NTLM Relay X. We give it this targets file. We want socks, and I'll explain in a second what that does. You want SMB2 support. All right. So what this is now doing, let's see, there was an error here. Yeah, it can't bind to 80 because I have a web server already running, doesn't matter. But this opened like an SMB server, same with the impacket server we had earlier, right? But now when it gets a request like we saw, it will actually relay the authentication to the system in targets.txt, which is the DC. And since this is a normal domain account that we get here from the XP tree, it will actually be able to access shares on the other machine because it's an authenticated user. At least it can list them, right? It can't necessarily access like any share because, well, permissions are configured in certain ways and so on, but it can at least list the shares. So that's what we are trying to do right now. So I'm just going to run this again here. And let's have a look at the output. It's telling us that it controlled the connection from SVC web staging. We saw that account earlier, and it's attacking the domain controller. It's authenticating with SMB against the domain controller, and it succeeded. And now it basically spawned a SOC server, and everything we send through the SOC server will be basically forwarded in the context of the user that we got, which is the SVC web staging user. So if we now do an SMB client using this spawned SOC server, we will be in the context of this account and no longer in the context like of an anonymous user, right? So now how do we use this? Well, first of all, we have to adjust our proxy chains config, which I think is spawning on 1080. Let me just... Yes, this is where it spawns. And now we can do like proxy chains, SMB client, like this. And then we do P user is reflection SVC web staging. Don't provide any password. And you can see that we can now list the shares. We couldn't do that before, right? And the reason for that is that we are now in the context of this SVC web staging user through the proxy because we relayed the authentication. Okay, so now we are obviously interested in this prod share we see. So let's go to that one. And we can access it. Let's get the proddb.conf. And we get a new set of credentials, and like judging by the format and everything, this is probably the same as before. It's credentials to connect to MSSQL. So let's do that. Now we do web prod, and obviously there's a new password. And we saw the second MSSQL database on DC. So let's put the DC IP here. And we could connect here as well. All right, let's repeat the enumeration steps we did earlier. So we do add version. Okay, looks to be exactly the same. We get our username. We are guest again, so this didn't really give us more privileges, but that's okay. Let's just enumerate databases again as well. And we see instead of the staging DB, now we have this proddb. So use prod. And then we do the query again to find the tables. Let me see. Oh yeah, I copy pasted this wrong. Obviously it has to be prot.information schema tables, and there's users table as well. So we can do select star from users. And we get a few more credentials, but these look a bit more real, right? This looks like a domain user, like with the dot in it and everything. And these passwords are also a bit more complex. So let's just try if we can actually use them on the domain now. So we can do CME LDAP, and then we put the IP, just this, username is Abby Smith, and then we do password, what we found here. And then let's try to like get Bloodhound data, right? Also put this here and see if it works. Okay, this seems to hang. Let's try CME SMB. Just leave the rest out here to see if the authentication itself is working. All right, this looks fine. So this user actually exists. Let's try the other one as well. Okay, so both of them are valid domain users, and what I wanted to do here is just dump the Bloodhound data, right? So, all right, I just rerun this command, and now it's working. The difference being that I added the hosts entries. Finally, I didn't do that in the beginning, so you need to have the correct hosts entry, and then it will just pull the Bloodhound data. And in the past, I used Bloodhound Python for this, but actually now that CME supports Bloodhound, I think this is a bit easier. All right, so I loaded the data into Bloodhound here. The first thing we can do is look for our own user, see if Abby has any like special permissions. Let's see, group membership. We are in staff and in domain users. Doesn't sound too interesting yet. Outbound is always interesting. Nothing too crazy here. And it seems that something is missing here. I know that because, well, I made the boxes, right? So I know there's something not being shown here. So let's rerun that. And I'm giving the see all parameter here to Bloodhound, so it collects a bit more information. So now after loading the data again, let's see if we can actually like find something new here. Let's go to outbound again. And yeah, this actually makes a difference. Now we can see that Abby Smith has GenericAll permissions on the MS01 computer object. And this is something we can exploit. So remember, if you run Bloodhound and, well, you don't really have to pay attention to detection too much, you can just use the CAll parameter here to collect like more information, right? Okay, so let's see what we are being told here. Generic all privileges to the computer. We know that, okay. And Bloodhound is suggesting to do RBCD, resource-based constraint delegation. So it wants us to create a new machine account and then set using the generic all on MS01 to set a specific attribute on it, which is this one here. MSDR is allowed to act on behalf of our identity to our new machine account. And then it would basically trust us to impersonate our users. So this is certainly something that can be done in normal circumstances. So let's see if we can do it here. One way to check is if we let's do CME LDAP and then MAQ as a module, which is machine account quota. And we can see the machine account quota is 0 here. So we are not allowed to create any computer objects. This is a bit of a problem, right? We kind of need RBCD to take control of this machine, but we can't create a computer. So if we just follow this edge here and follow Bloodhound's suggestion, we can't proceed because we don't have a machine account yet. So one other thing you can do is if you have generic all, it essentially means that you can read any attribute on the object or write any attribute on the object. And one thing to read in case it's used is the labs password. So if labs is being used, the computer account password is actually stored in a Active Directory attribute, and certain users are able to read it, or certain groups. And if we have GenericAll, we can also read it, right? So one way we can do this is by using LDAP search directly. So this is what I'm going to do here. We do LDAP search, then we point this at the correct IP. Then let me copy a bit of stuff here. We give it the username, we give it the password, and we give it the OU we want to read from, which is this computer account is in the server's organizational unit, right? And then we give it the attribute we want to look for, which is this one. We're basically telling it to look for computers in this OU and then look for this attribute. MSMCS ADM PWD, which is the lab's password. So if we just run this, we actually get the lab's password back here. And you didn't really know that this machine is running labs yet, but you can actually either see it in Bloodhound or just like attempt it, right? There's only so many things you can do with GenericAll, so might as well just try it, right? Also, if you look like here, I think there's like a labs group or something. Yes, labs policy. Okay. So now we have the labs password, which is the local administrator password. So we can just do like evil winrm administrator. And yeah, we got a shell on the first machine and we can read the first flag. All right, so now that we have an admin shell, one thing we always want to do is like dump credentials, right? You can use Mimikatz to do it or sharpdp API or whatever tools you prefer. Obviously, there are also other steps you can do like enumerate the box further, but we're going to start with credentials here. This is not like a red team lab, so you can just disable the AV, right? And then we upload sharpdp API to the box. And then we can just run it. Let's do sharpdp API and then machine triage. See if anything interesting is in here. Doesn't look too interesting. Nope. This one looks good. So there's a scheduled task on the machine which is running as another domain user, which is Georgia Price. So let's save that here. And let's just see if Georgia can do anything interesting. All right, this is interesting. It looks exactly like the thing we saw before, right? Georgia has also GenericAll, but this time not on MS01, but on WS01. So Bloodhound is of course going to show us the exact same thing, create a machine account, and so on. But we still can't do that, right? Georgia can't magically create machine accounts. So what's the difference now? Well, we can also try to read the labs password on this one, but it won't yield anything because there's no labs on this box. So we are really stuck with exploiting RBCD here. We just have to find a way to get a machine account somehow. Well, we just compromised the machine, right? So we essentially have a machine account we can use, the one from MS01. Let's now actually upload Mimikatz here. And then I'm just going to elevate and then do secrets logon passwords. And if we go up here a bit, we should get the machine account. Yes, it's this one, right? So now we do have a machine account. We didn't need to create one. And this actually allows us to now exploit resource-based constraint delegation. All right, so let's exploit this with Impacket. So what I did here is Impacket RBCD. I'm just giving it a target, which is WS1, the DCIP, and I want to read. And this implicitly basically tells it to read the attribute here, MSDS allowed to act on behalf of our identity. And what this attribute is doing is basically deciding on WS01 which other machines it trusts to identify users. And currently it's empty. So now what we want to do is basically modify this command. We do delegate to, we keep this the same, but here we can do delegate from we do MS01 because that's the only other machine account we have control over. And instead of read, we want to write the attribute. We want to put MS01 there, right? So let's do that. All right, it told us it modified it, but we can also like just read again to confirm. And yeah, now you can see if we do read, like in the beginning, it actually tells us that MS01 is there. So now MS01 is indeed allowed to act on behalf of other users. So how do we actually now like get admin on the box, right? Well, we can just get a service ticket if we authenticate as MS01 and impersonate the administrator. And we are going to do that like this. Impacket get service ticket. The SPN we want is sys because we want to access the file system. We want to impersonate the administrator, and as authentication we have to give it MS01 because that's the account that's allowed to do it. And we dumped the hash earlier, so this hash here is wrong. I had it in my notes. We have to use the actual hash here that we just dumped. So let's see if we get one. Yes, it actually saved the ticket, so this looks kind of good. Now we just have to do an export like this. Let's do a klist. Looks like the ticket was loaded correctly. I'm not going to use Linux for this. I'm going to show how to use it on Windows. So I did psexec to MS01, which we already had, right? And then I'm going to use Rubius. So let's go to temp. I already put Rubius here. And what we want to do is use the same thing we just did with Impacket to get the service ticket just via Rubius, like this. It's essentially exactly the same thing. We give it the domain credentials for MS01. And we want to impersonate the administrator, sys, and so on, right? It's exactly the same thing. Let's see. Oh, it actually had the wrong hash again. Apologies. So let's run it again. Yes, so this is working, right? We got a ticket as this user, and now we should be able to do a listing here on C. And yeah, we have access to WS01 now. And this would be enough to read the flag, right? But we actually want to get a shell here, so... All right, so I'm going to download psexec, and I'm going to download it from my machine onto MS01 first here. All right, and then what I want to do is run a command on WS01, and the command I'm going to run is this one, psexec on this machine, right? And then I run an executable file from a file share on the attacker machine. And I'm going to run rcat, which is like a simple reverse shell tool I've written a while ago. So we just have to place it here, right? See, I already have it here, but rcat basically supports that you provide the IP address and port inside the file name. So we can copy this into this file name. And now when you execute this file on Windows without any parameters, it will actually connect back to our machine on this port, right? That's the big advantage. So all we're doing is psexec executing a file from our file share. Obviously, we also need listener. You can see an authentication attempt here. And here we have a shell. Let's see, hostname. Yes, we are on WS01. And just as before, we can just disable Defender here because, well, being stealthy isn't important in this lab. Let's actually create a temp folder here. Also make this an exclusion, just to be on the safe side. Then we go to this temp folder and let's download Mimikatz like this. And then we just run Mimikatz. Let's do same command as before, right? Token elevate, privilege debug, secure LSA logon passwords. That's the staple. Then we see if we can find any other credentials here that would be interesting. Let's see. And there's another user here, which is Riz Garner, and we even have the clear text password. All right. Again, back to Bloodhound, see what this user can do. It was like Riz, yeah. Let's see. All right, any high reachable value targets? Not really. Maybe Outbound says something interesting. Nope. if we just do like ris here, okay, let's do garner. This is something interesting, right? So this ris garner person has another account, which is dom garner. And this is fairly common. So they use like a tiered administrator model, and this user has basically two accounts, right? One for their domain admin stuff and one for their normal user stuff. And this account is, well, this is a domain admin, right? So if you're lucky, this user might have used the same password on both accounts, right? Not that uncommon, to be honest. So we would want to try this account here, dom garner, and then this password, right? Then we paste the password. And this actually worked. We can go here and read the final flag. Oh, it's actually not here. It's on the administrator, I guess. Yes, and also on WSO1 there was another flag, so basically one on each of the machines, right? And that's basically it for the chain. Alright, thank you for watching, and if you want to try this chain or one of the many other chains we have, you can go to vulnlab.com to get access to the labs. Thank you and see you next time.